Hi guys, we are here today to solve some problem in organic chemistry. So our first problem is why can't organic molecules have the formula C2H7? Because carbon has 4 valence electrons. One of these valence electrons is used to form carbon-carbon single bond. So this is the carbon-carbon single bond. This means that every atom of carbon has 3 valence electrons left. So there are 3 valence electrons left in each of these carbon. And this 3 valence electron per carbon of atom will be utilized by hydrogen. So this valence electron left will be utilized by 7 hydrogen. 1, 2, 3, 4, 5, 6. So there are 1 hydrogen left. So that's why we can't use this formula, because there are only 6 hydrogen in carbon-carbon single bond. The right formula is C2H7. Why? Because in carbon-carbon single bond, there are 6 valence electrons in each of these carbon. So this 6 valence electron will be utilized by 6 hydrogen. 1, 2, 3, 4, 5, 6. So this formula is correct. So we'll proceed to our second problem. Our second problem is which element in each of the following pairs has more electronegativity. So our first pair is Le or H. So we will determine which of these two has the higher electronegativity. So the element Le is lithium and H is hydrogen. The element hydrogen has more electronegativity than lithium. Why? Because hydrogen has 2.1 electronegativity. So hydrogen H has 2.1 electronegativity, and Le or lithium has 1.0 electronegativity. So hydrogen has the higher electronegativity because hydrogen electronegativity is 2.1. So that's all. So let's proceed to our third problem. Our third problem is use the partially positive and partially negative convention to indicate the direction of the expected polarity. So our first problem is carbon or bromine. So we'll determine which of these two elements has the higher, which of these two elements is partially positive and partially negative. So carbon has 2.5 electronegativity and bromine has 2.8 electronegativity. So carbon is partially positive and bromine is partially negative. Why? Because carbon has a low electronegativity, so it is positive, and bromine has a high electronegativity, so it is negative. So that's all. So So let's proceed to our fourth problem. Our fourth problem is order the band in the following compound according to their increasing ionic character. So we will order the band of these elements. So first, we will find we will find their differences. So first, we will find the differences of these two elements, carbon and chlorine. So it's easy. We will just put their electronegativity. So the electronegativity of chlorine is 2.55, and the electronegativity of chlorine is 3.16. So we will just subtract these two to find its differences. So 2.55 minus 3.16 is equal to 0.16, and then we will proceed to these two elements. We will find their differences. So magnesium and chlorine. So the electronegativity of magnesium is 1.31 and chlorine is 3.16. So we will subtract these two. 1.31 minus 3.16 is equal to 1.85. So let's proceed to this third element. So our third bond is Ti, titanium and chlorine. So the electronegativity of titanium is 1.54, and the electronegativity of chlorine is 3.16. So we will subtract these two. 1.54 minus 3.16 is equal to 1.62. So let's proceed to this last bond. Bond of chlorine and oxygen. So chlorine and oxygen. So chlorine has 3.16 electronegativity and carbon has 3.44. So we will subtract these two. So 3.16 minus 3.44 is equal to 0.28. So after finding their differences, we will order their band compound according to their increasing ionic character. So first, we will put Cl20 greater than less than C and Cl4 less than TiCCl, and the last is NG So this is the ordered band of the following elements to their increasing ionic character. So that's all.
A few moments later.
So this is our discussion of lesson 2 learning activity. Problem 1.1. How many electrons does each of the following elements have in its outermost electron shell? Letter A, potassium. Potassium has 1 electron in its outermost shell. This sign I show you. This sign is 1. Okay. Electronic configuration of potassium. 1 is to the power of 2. 2 is to the power of 2. 2 is the power of 6. 3 is to the power of 2. And 3 is the power of 6. And 4 is the power of 1. B. Calcium. Calcium has 2 electrons in its outermost shell because they have 2 in this, right? Calcium. Electronic configuration of calcium. Calcium has 1 is the power of 2. 2 is the power of 2. 2 is the power of 6, and 3 is the power of 2, and 3 is the power of 6, and 4 is the power of 2. Now let's go to number 3. Aluminum. Aluminum is the letter C. Electron shell of aluminum. Aluminum has 3 electrons in its outermost shell, just like this. 3, 1, 2, 3. Electron configuration of calcium. Aluminum rather. 1 is the power of 2. 2 is the power of 2. And 2p 6. 3 is the power 2. 3p is the power of 1. Problem 1.2. Give the ground state iron configuration of following elements. Based on my answer, letter A, boron. Ground state electron configuration. 1 is the power of 2, 2 is the power of 2, and 2 is the power of 1. Configuration is power of 1. This is our configuration. This is our configuration. It's like that. 1 up and 1 down, and also the 3. Insert. Yeah. And that's all our problem. 1.2. Letter B. Phosphorus. Ground state electron configuration. 1 is the power of 2, 2 is the power of 2, and 2p is the power of 6, 3 is the power of 2, 3p is the power of 3. Our configuration of 1 is 2, like this. This also. This is my answer. 2 is the power of 2 and 2 is the power of this. Now let's go to number letter C. Oxygen. Real state electron configuration is 1 is 2 and 2 is 2. 2 and 2p is 4. Configuration. This is our configuration. 2 is 1 is 2, 2 up and down, and 2 is the power of 2, and 3 power of 4 because they 2 and down. Now let's go to 1.6 problem. Write both electrons do net and line band structures for the following molecules showing all non-band electrons. A. CHCI. Fluoroform. These are electron dot. C is point and 2 in this side and 2 in this side, just like and our line bond is like this: C H and like that, and B H is power H2 is power of hydrogen sulfate. Electron dot is H and 2 point in the side by side, and this is our line band, and H, S, and H like that. C CH3 and NH2 methylamine. This is our electron dot. H in the